Variance and standard deviation. To describe how much a set of data varies from its mean statistically, you can use several different measures of variability. One measure of variability you have already learned about is the mean absolute deviation. This measure uses absolute value to counteract the fact that some deviations from the mean will be positive and some will be negative. Another approach is to square each deviation, resulting in all positive numbers. The mean or average of the squared variations is a measure of variability called the variance. The symbol sigma squared represents the variance of a population, and the symbol s squared represents the variance of a sample. Variance is expressed in square units because it is the mean of the squares of the deviations. You can take the square root of the variance to find the standard deviation, another measure of variability in a data set. The standard deviation is expressed in its original units of measurement of the data. The symbol sigma stands for the population standard deviation, and s stands for the sample standard deviation. So here we have three measures of the variability of data. We can calculate the MAD, the variance, and the standard deviation. The difference between the MAD and the variance is that the MAD uses absolute value while the variance is squared. The variance and the standard deviation are similar, but their difference is that the standard deviation is the square root of the variance. So to define it, variance is represented by sigma squared. It's the average of the squared deviations. So how do we calculate that? We start with x sub I minus mu, and we square those numbers so they're positive. Then we add them all together, so we'll put a sigma here, and divide by n, the number of elements in the data set. And that is sigma squared, our variance. The standard deviation is the square root of the variance. So once we calculate the variance, we take the square root, you've got the standard deviation. It measures how the data varies from the mean, and it's represented by just the small sigma. So to do that, we start again with our data element, x sub I minus mu. We square it. We add all those positive numbers together, and we divide by n. So this is our variance. To make it the standard deviation, we then take the square root of that number. So sigma is equal to that. We'll also be calculating z-score. A z-score tells how many standard deviations a number is from the mean. So you could represent standard deviations with a little sigma here. All right, so z is equal to the data element x sub I minus mu divided by the standard deviation, or sigma. So let's compute the variance and standard deviation. The table below shows the ages of dogs available for adoption at the Fairfax County shelter last week. You found that the mean age for these dogs is 4.082 years, which will round to 4. None of the dogs is exactly that age. How much older are these dogs on average than 4? So go ahead and compute the variance. Remember that the mean is 4. So our mean is 4, our variance is 65.83 divided by 11, which is approximately 5.98. Once I have the variance, if I take the square root of 5.98, it's approximately 2.45, or I'll round to 2.5. That is our standard deviation, the square root of the variance. So that was computing it by hand. But another way we compute it is to use our graphing calculator and enter the data set into our list, and then run a 1-bar stats test. And we can see that indeed our x bar, or our mu, is 4, And then our sigma is 2.45. Now, if I wanted to find my variance using this, I would just have to square my variance. Since the standard deviation is the square root of the variance is the standard deviation squared. So the average, the sum of these values divided by n is 5.98, and that's the variance. When we change the distance back into years instead of years squared, if we square root the number, that gives us our standard deviation. So the square root of the variance of 5.98 is approximately 2.45. So that means on average the dogs at the shelter are about 2.5 years older or younger than the average age of 4.